Hello future engineers and my dear students, welcome back to Mudassar Academy and welcome to the third video of the module 1, that is polar curves. In the first video, we derived two major derivations which are asked in examination for 5 to 6 marks. In the second video, we solved problems relating to angle between the radius vector and tangent vector for polar curves. In the third video, that is today's very important video, we are going to solve exam related problems relating to angle of intersection between two polar curves and orthogonality of two polar curves. These problems are very important and they keep on repeating in the examination for 5 to 6 marks. So please students, whenever I teach, please take it down separately and in a separate notebook so that it will be very handy and easy for you to refer before internals and examinations. Okay, now before moving on, I will request you to refer my second video if you haven't. Go to the video, solve those problems, because if you're able to solve those problems, then later these problems will be very easy for you. Solve those problems, write down the formulas on a separate sheet of paper and keep it handy before solving it. Or if you want to, if you need a PDF, please find a link in the description below. Now, moving on to the problems based on angle of intersection between two polar curves and orthogonality. So first, let me brief you about the formulas which we discussed in the last class. So the formulas were cot phi is equal to 1 by r dr by d theta, sin theta is equal to 2 sin theta by 2 into cos theta by 2, 1 plus cos theta is equal to 2 cos square theta by 2, 1 minus cos theta is equal to 2 sin square theta by 2, and cos theta minus sin theta upon cos theta plus sin theta is equal to cot pi by 4 plus theta. Okay. Now moving on to the problems. In finding the angle between the radius vector and tangent vector phi, we applied log on both sides, then principles of log, then we differentiated, then the left side always is cot phi and right side we make in terms of cot phi and you find angle phi. But for problems relating to angle of intersection between two polar curves and orthogonality, there will be two curves given. So for both the curves, we need to apply the same technique, okay, and find phi 1 and phi 2. Now, the angle of intersection is given as modulus of phi 1 minus phi 2 or mod of phi 2 minus phi 1, because angle is always positive. Okay, so this is the formula to we find phi 1, we find phi 2, just subtract it and there we get the angle of intersection. Now if this angle, that is phi 1 minus phi 2 is equal to pi by 2 or 90 degrees, we call it orthogonal or perpendicular. So in the question if they ask, show that the two curves intersect orthogonally, then we need to simply find phi 1 minus phi 2, and if the angle is 90, they intersect orthogonally. And one more condition is there, you might learn in your 11th or 12th grade whatsoever. So if the slopes of the two lines, that is tan of phi 1 into tan of phi 2 is equal to minus 1 or m1 into m2 is equal to minus 1, then also it is said to be perpendicular or orthogonal. Okay. Now, taking this theory or facts into mind, we will be solving the problems later based upon angle of intersection between two polar curves and orthogonality of two curves. Okay. Okay, then let's start solving the problems. But before solving the problems, please consider subscribing because it's more beneficial to you more than me. Fine. Now, starting with the problems, first problem is show that the curves r is equal to a into 1 plus cos theta and r is equal to b into 1 minus cos theta intersect orthogonally. Fine. So first we'll solve problems related to orthogonality, and the second video will solve problems relating to angle of intersection between two polar curves. Right? So now, bringing the first question. So first, as I told you, there are two curves given here. I write on the curves here. R is equal to a into 1 plus cos theta and r is equal to b into 1 minus cos theta. Fine. Now we do the same technique here. apply log on both sides. Log r is equal to log of a into 1 plus cos theta. Am I right? Now, apply the principles of log. So, please, if you written down in separate sheet, please refer the formulas here. Log a into b is log a plus log b. Inside a bracket is again a single function. I'll keep on repeating this so that it gets fitted into your mind and you never make any mistakes further. So, log of r is equal to log of a plus log of 1 plus cos theta. Now, everything is perfect. Differentiate. So, 1 by r into dr by d theta is equal to 0 plus 1 plus cos theta, and differentiation of log of 1 plus cos theta is, so log of x 1 by x, so log of 1 plus cos theta is 1 by 1 plus cos theta. Again, 1 is 0 and cos theta is minus sin theta. Therefore, cot of phi is equal to minus 2 sin theta by 2 into cos of theta by 2 upon 2 cos square theta by 2. Again, refer the formulas, because the formula for sin theta is 2 sin theta by 2 into cos theta by 2, and 1 plus cos theta is 2 cos square theta by 2. That means cos and cos cancels, 2 and 2 cancels, we get this yields, that implies cot of phi is equal to minus tan theta by 2. Okay, now we can write minus tan in terms of cot as cot of pi by 2 plus theta by 2. Therefore, the first angle I will take this as phi 1 is equal to pi by 2 plus theta by 2. Okay, so we have found the first angle now. Now moving to the second part, r is equal to b into 1 minus cos theta. We will do the same here. Log of r is equal to log of b plus log of 1 minus cos theta. 1 by r dr by d theta is equal to 0 plus again 1 minus cos theta. So, differentiation of log of 1 minus cos theta is first log, x is 1 by x. So, log of 1 minus cos theta is 1 by 1 minus cos theta. Again, differentiation of 1 minus cos theta will be 0 minus of differentiation of cos theta is minus sin theta. So, minus into minus becomes plus. So, sin theta. Okay, that implies cot phi is equal to 2 sin theta by 2 into cos of theta by 2 upon 2 sin square theta by 2. 2 cancels, sin cancels. Now, what is cos by sin? It's cot. That implies cot phi is equal to cot of theta by 2. Therefore, the angle is, I will take this angle as phi 2 is equal to theta by 2. So, I have found both the angles now, phi 1 and phi 2. So, as discussed, the angle of intersection between two curves is given as phi 1 minus phi 2. So, if you find phi 1 minus phi 2 is equal to pi by 2 plus theta by 2 minus theta by 2. So, this cancels. That is again nothing but pi by 2. Pi by 2 is how much? 90 degrees. Therefore, we can conclude that the two curves intersect each other orthogonally. So, that we can write the two curves are orthogonal. That's it. Now, moving to the next question, show that the curves r is t n is equal to a is t n cos and theta and r is t n is equal to b is t n sin theta intersect orthogonally. So, we do the same thing here. So, first curve is r is t n is equal to a is t n into cos n theta. Now, apply log on both sides. Log of r is t n is equal to log of a is t n into cos n theta. Again, what is it? Log r is to n. Therefore, the formulas log a is to k is always k log a. So, n into log r is equal to again log a into b is how much? Log of a plus log of b. So, that means n log r is equal to n log of a plus log of cos of n theta. This is what we have. Fine. Now we can differentiate. So, if you differentiate, we get 1 by r dr by d theta equals 0, because see, log of ABC, NMOP, whatever it is, it's 0 only. Okay, because we're differentiating with respect to theta. Now, differentiation of log of cos and theta. First, log is 1 by, differential log x is 1 by x. So, log of cos and theta is 1 by cos and theta. Again, differential of cos and theta will be minus sin n theta. Again, differentiation of n theta will be n. Okay, so I forgot a n here, sorry. So now n and n cancels. Fine. That implies cot of phi is equal to minus tan of n theta. That is, we can write minus tan in terms of cot as cot of pi by 2 plus n theta. So cot of pi by 2 plus n theta. Now here cot cancels. So the first angle phi 1 will be pi by 2 plus n theta. Okay, so you found the first angle now. Now moving to the second equation. What is second equation? Is r raised to n is equal to me raised to n into sine of n theta. So again the same thing. So apply log on both sides. So log of r raised to n is equal to log of b raised to n into sine of n theta. That means we have n log of r is equal to log of a into b log a plus log b log of sine of n theta, right? Therefore, we can write n log r is equal to again log b raised to n. Log a raised to k is k log a. So, n log of b plus log of sine of n theta. Now, we can differentiate this. So, n as it is into log r is 1 by r dr by d theta is equal to 0 plus again differentiation of sine, log of sine theta. Log of x is 1 by x, so 1 by sine of n theta. Perfect. Again, differential of sine theta is how much? Cos theta. So sine n theta will be cos of n theta. Again, n theta is into n. So n cancels here. We have, that implies cot of phi is equal to, what is cos by sine? Sine by cos is tan. So cos by sine is cot. So we have cot of n theta. Cot cancels. That implies the second angle phi 2 is equal to simply n theta. So now as I have found both the angles phi 1 and phi 2, so the angle of intersection we need to find, and if it's coming as 90 degrees, it is orthogonal. Therefore, phi 1 minus phi 2 will be pi by 2 plus n theta minus n theta cancels. So that is pi by 2. That is nothing but 90 degrees. Therefore, we can conclude that the two curves intersect each other orthogonally. That's it. Finished. I hope you understood the question clearly. Okay, see, what I have done is, I have taken these two curves together written like this. So in examination, the paper won't be sufficient. So you can write down first this curve and you can name it phi 1, and second part you can write this curve, name phi 2, and then you can subtract the angles. You can do like that. Okay, fine. So moving on to the next problem, we have show that the curves r is equal to a into 1 plus sine theta and r is equal to a into 1 minus sine theta intersect orthogonally. So we apply the same technique here. First, r is equal to a into 1 minus 1 plus, r is equal to a into 1 plus sine theta. So what we do? We apply first log on both sides. That is, log of r is equal to log of a into 1 plus sine theta. Now apply the principles of log. Log r is equal to log a into b is log a plus log of b. Now you can easily apply differentiation here. So log of r differentiation is 1 by r into dr by d theta is equal to 0 plus again log of 1 plus sine theta, 1 by 1 plus sine theta, because differential log of x is 1 by x. So log of 1 by 1 plus sine, log of 1 plus sine theta is 1 by 1 plus sine theta. Again 1 is 0 and sine theta is cos theta. So we get cot of phi is equal to cos theta by 1 plus sine theta. So I will take this as cot of phi 1. Okay. Now the problem here is I'm not getting anything like, cot, and I'm not getting directly angle. Okay. So what I'll do, I'll leave it till here and move on to the second equation. What is the second equation? R is equal to A into 1 minus sine theta. So here also, I'll do the same stuff. That is, apply log on both sides. Log of R is equal to log of A into 1 minus sine theta. Again now, log of R is equal to log of A plus log of 1 minus sine theta. Okay. Now we differentiate. That is 1 by R into dr by d theta is equal to 0 plus, again this will be 1 minus sine theta. Again differential, 1 is 0 and sine theta is minus cos theta. So here this becomes cot, I'll take this as cot of phi 2 is equal to minus cos theta by 1 minus sine theta. Now, as you see here, in the previous problem, we used to directly get the values for phi 1 and phi 2. We used to subtract and get the angle and show it's orthogonal. But in this case, we cannot move anything further. So remember, I told you one thing. Okay. If not by this, there is one more thing to show that the two curves are orthogonal. That is, the product of the slope should be minus 1. That is, tan phi 1 into tan phi 2 should be minus 1. So what I'll do here is, cot phi 1 is equal to cos theta by 1 plus sine theta. That implies tan of phi 1 will be what? Opposite of it. So this will be 1 plus sine theta by cos theta. Similarly, tan of phi 2 will be minus 1 minus sine theta upon cos of theta. Am I right? So, if you see this here, sine of theta. Okay. Now what I'll do, I'll simply multiply it. That implies tan of phi 1 into tan of phi 2 is equal to 1 plus sine theta upon cos theta into minus 1 minus sine theta upon cos theta. Fine. That means, what is this? 1 a plus b a minus b, this will be minus outside as it is. A plus b a minus b. 1 a plus b a minus b is a square minus b square. So 1 plus sine theta into 1 minus. So moving on to the next problem here. Show that the curves R is equal to A e raised theta and R e raised theta will be intersect orthogonally. This is the last problem of this video. Fine. So first, as usual, R is equal to A e raised to theta. Apply log on both sides. Log of R is equal to log of A e raised to theta. Now, log of R is equal to log A into B is log A plus log of B. That means log R is equal to log of A plus theta log E. Recall the log formulas. Log A raised to K is K log A. Now, what is log E? Log E is always 1. Log E is always 1. So, what is that? Remember, log of R is equal to log of A plus log E is always 1. Remember it. Fine. Now, differentiate. So, 1 by R, dr by d theta is equal to 0 plus 1. That implies cot of phi 1 is equal to 1. Fine. Therefore, I can write here. Okay. We'll move on to this. Then let's see this. Okay. Next equation is R e raised to theta is equal to B. So, log of R e raised to theta is equal to log of B. Again, log A into B is log A plus log B, log A plus log e raised to theta is equal to log of B. Now, again the same thing. Log A raised to K is K log A. So, log of R plus theta log of E is equal to log of B. That is, log of R plus theta is equal to log of B, because log is 1. Now we can differentiate. Fine. So, differentiation of log R is 1 by R into dr by d theta is equal to, d theta plus differentiation of theta is 1 is equal to 0, because log A, B, C, M, N, O, P, everything is 0. That means we get 1 by r dr by d theta is equal to -1. That implies cot of phi 2 is equal to -1. Now, since we need to show the curves intersect orthogonally, so cot phi 1 is 1. What is tan phi 1? Tan phi 1 is also 1. And what is tan phi 2? Tan phi 2 is also -1. Therefore, if tan phi 1 is 1, what is phi 1? What value of theta or makes tan equal to 1? It's very simple. It's pi by 4 because tan of 45 degrees is always 1. So, phi 1 is equal to phi 1 is equal to pi by 4. And we have phi 2 is equal to minus pi by 4. Therefore, the angle of intersection phi 1 minus phi 2 is equal to pi by 4 minus plus pi by 4, that is nothing but pi by 2, that is 90 degrees. Therefore, if it is 90 degrees means the curves intersect each other orthogonally. Curves intersect orthogonally. That's it. Okay. So in today's class, we solved problems relating to orthogonality of polar curves. I hope you understood the solutions clearly, and I'm very sure you like the way I teach. I try to make maths very simple as possible to my students. But in case if you have any doubts, then please post in the comment below. The next video is very important. I will be solving more and more problems relating to angle of intersection between polar curves, which they asked in the examination for 5 to 6 marks. So stay tuned, hit the bell icon, and if you haven't, please click the subscribe button now, like it, share with your friends. Till then, see you in the next video. Do the practice, do the maths. Bye.